First thing I'll do is I'll delete this bottom floor thing because I don't need it. I actually want to, what I want to do is actually build a wall around the whole shape, but not in the screen at all. So I'll do that after, but I'm going to delete that for now. I'll also delete this is left mouse button clicked so that I don't have little blocks flying around the screen when I click my mouse. Right, I don't want those either. There you go. Those are gone. So there's nothing in there right now. And then what we're going to do is we're going to make our own ball variable. So we want to eventually be able to go like this. Ball, like that, and then write a variable name, B1. Okay? And then we'll have our own ball, and it'll have all the properties of a physics circle, create circle shapey thing, and we might even give it our own commands, like maybe we want to go b1.check paddle collision or something. That will be a goal for us to add our own little commands to the end of this ball variable that we make. We've never done that before, so let's do it. We could do it up here, but it's best if we actually do it in a separate file so that the code is tucked away somewhere. So I'm just going to go File, New, Empty File. It'll ask me if I want to add this to my active project. Of course I do. You can see all my files there. I'm going to call this one ball with a capital B, because I'm going to call it with a capital B, .h. See that? Ball.h. Stands for header file, but should be good enough for what we're doing. Maybe it's CPP. Maybe we have to use CPP. Call it ball.cpp. We'll find out in a minute. Let's write this thing now. Okay, so what the code we're going to write is we're going to write the word struct, which is going to make our ball variable for us. And then we're going to write curly brackets like that. That's it so far. Okay. That's all it is. If we save that, it has a semicolon at the end of it too. So if we save that, we can include it in our project. Include ball.h. It already sees it there with a capital B. And when I run it, I can make my own ball object now, my own ball variable. Call it B1. It does nothing, but that's how you make your own variable type. There you go. Empty screen. Okay. It's in a separate file, but basically all this file does is say, take all this code and write it here when you press F9. So it just keeps it a little neatly away from where we want it to be. So that's good. Okay. So what is this object going to have? What is our variable going to have? What does a ball need? It needs a position for the X and Y. It needs velocity. It needs collision. It needs all kinds of physics stuff as well. So what I might do is steal all of the code from create circle. Want to do that? I'm just going to grab the word create circle. I don't need that word block, and I'm just going to steal it. Copy. That's in the physics.h file, by the way. So I'm going to paste that here. Boom. That's pretty crazy, isn't it? Instead of create circle, I'm going to use the word ball. We'll define what that means in a minute. Everything else should be good. Let's see. It's going to complain to us a lot because we're missing all of this physics stuff right now. So it won't know what B2 body def is. It won't know what B2 shape is. These are all box 2D things. It won't know any of that stuff. It won't even know what shape is. It won't know anything about SFML because we didn't include any of that stuff in this file yet. So we're going to have to do that in a minute. But let's run it and see what kind of errors we get. It doesn't need a return. Okay, fine. No matching function call. Now it needs, look at this, by the way, guys. Just by calling this function ball, the same name as my actual variable type, now when I go to type in a variable, it needs all the numbers that I was passing originally. It needs a world, it needs a float, it needs a y, an x, an r, and a body type. So if I give it the world and I give it an x, I want it in the middle of the screen, let's say, 300, or 400, 300, and I need a radius, and I'm not going to give it a body type, then I run it. Now it likes, oh, it actually ran. That's nuts. Did you see it actually made a ball too? Look at that. In the middle of the screen. It's kind of cool. I guess since physics has all been included here, then when I go to make the ball object, it's also included in there. But just to be on the safe side, I'm going to include it. Include physics.h, so that my ball variable will know everything it needs to know, have access to all the physics commands. There you go. I actually drew a ball. Kind of neat. Let's see if we can get it to change size. Let's see if we can get it to be 100. Yep, it works. I think for now we're going to turn off gravity though. We don't really want gravity in our Pong game. Maybe as like a special feature later on, but there's the ball. It's not doing anything yet, but I'm going to give it some velocity in a second. Okay, there we go. I've made my own ball variable, and I've named the first one I've ever made called B1, and if I want to do stuff with it, I can go B1. There's not much I can do with it right now. It has no data associated with it. So let's clean that up. Okay. This, by the way, this function that gets called when you make the thing is called the constructor, because you're constructing the variable or object. This is all the box 2D code that it does. It makes a body definition. It sets the position to the x and y. It gives it the type you told it to give it. It gives it a linear dampening, which we probably want to set to 0. We don't want our ball to slow down over time. It gives it a shape. It gives it a radius. It gives it a fixture definition. So that can give it density, friction, and bounciness. We probably don't want it to have any friction, right? It's going to be bouncing off of the walls. We don't want it slowing down every time it does that. We probably don't want it to lose energy when it bounces either. So I think here we put that to 0 as well. Then it does shape, and it makes some sort of B2 body that creates it, and so on and so forth. So we're going to change something in here. What we're going to do is we're going to write, like here, B2 body star, and then we're going to write body there. So this thing now has its own box 2D body variable. Okay, because I can not only give this thing commands like functions like this one, but I can also give it variables to keep track of stuff. So if I go here now, I can actually, if I go B1 dot, you can see that I can get a hold of the body variable and do stuff with it now. I think you can apply all the box 2D commands you want to it. Get angle, get inertia, get position, all that stuff. All right, so that's good. I probably also want to have an SFML circle shape to keep track of this thing too. What do you think? Here's a crazy way to do that. I'm going to include Will physics do it? Yeah, physics already includes all the SFML stuff here, so we're good. So we actually don't need to include SFML stuff. But what we need to do is go like this. When we make our command, if we write the name of a different variable type, so I'm going to use SF : circle shape. Like that. I think that's right. This thing will take on all the properties of the circle shape. It will inherit them all. Okay, what does that mean? It means that ball is now not only all the stuff we're going to give it, like physics and everything, but it's also going to have all the same, like for instance, you could see here, if I wanted to change the color of B1, I wouldn't have been able to. There was no B1.setColor originally, but you can see now it's got all the same SFML options now, which is really nice, right? So it's got my options. Right now I only have one, which is the body, but it also has all the same stuff. Like I can go B1.setFillColor. Is there a set fill color? Yeah, and I could change the color of my ball now to blue. That actually won't change it, I don't think, yet, until we... No, it won't yet, but it will in a minute once we get that figured out, okay? So I'm just going to write a little message here that says, takes all circle shapes properties. You can tell why I probably don't like to teach this way to code a lot. It's good for Brick Breaker because we're going to make our own stuff, but like basically making all these structures or classes and they're all taking on each other's properties and it gets really messy really quickly. There's not a lot to be learned when you're first starting to code by coding like that. Okay, so let's get rid of a few other things. I want to, first of all, I want to get rid of, I don't need any of this anymore. Okay. I don't need any shape stuff. I do need the set origin command, and I do need the set position command, and I do need the set fill color command. But they're just on their own now because this thing is acting like a circle shape now. So all I have to do is just call the circle shape commands and it'll do them. So I could actually make this thing blue by just typing it here. Blue. If I run that, it doesn't like this res thing, so I can get rid of that. It's not going to draw anything. It might even crash. No problem. Here, I'm going to replace this with the word body. This is the body that I have, that I've made. Okay. And here I'll replace this with the word body. I wonder if that'll work. Still gonna crash? Yep. Body equals world dot create body. Body equals create fixture. Yes, okay, good. Now, what's the last thing I gotta do? I think I gotta get rid of the display world command, guys. We don't need it anymore. We're not gonna use it. We're gonna draw our own stuff. There, it doesn't crash anymore, so that's good news. How are we gonna draw this thing? Same old way we used to always draw it. Window.draw. Just give it the name of the thing you want to draw. For us, it's the ball we made. Because it took on all the properties of a circle shape, it should have no problem drawing it. Should just be drawing. No, it doesn't draw yet. Let's go figure out why. It's got an origin, it's got a position. It doesn't have a size, does it? Set radius to R. That should fix it all. That should draw it for us. see if it draws a blue circle in the middle of the screen, and it does. Okay. So what we've basically done is we've created our own variable type, also known as an object. It's taken on all the properties of circle shape, so it has all the same stuff an SFML circle shape would have, except underneath the hood, we're adding physics to it. So we just ripped off a lot of the physics commands that were in the physics file. And so if I go to make basically this SFML shape, instead of, in the past when I would make a circle shape, I would come in here and I would write, you know, circle shape, whatever, C1, and then I could give it a radius, and then that would draw a circle for me. Now, I've changed it so it's the word ball. It has all the properties of circle shape. We'll call it B2. And now it's asking for physics stuff. So we're going to kind of just blend the two together into our own kind of hybrid type that is going to nicely take all the properties of SFML, but run the physics underneath it so that we don't really need to know how it does that. Okay, so let's see what happens. If I set my gravity back to 9.8, should this thing fall? Yes, it should. But it's not falling. Okay. Weird. So let's figure out what's happening. Let me go into my physics file and look at the get position command and see how the person who made this was getting the position of a block. Set velocity, limit block. There's get position right there. Okay. So let's steal that command. SFML position. All right. I'm going to steal this. Vector 2F. Is that right? Sure. I'm going to copy this whole thing. I don't need that word inline. Don't worry about that. It's for another day. But I'm going to go outside of this ball. I'm going to go outside of this function, and I'm going to make a new function in here called getPosition. Okay. It doesn't need the name of anything. Okay. Because I already have a variable keeping track of its body, so I'm just going to replace the word letter B with body. Body. Okay. So now my ball variable now has a get position. Now it has a get position function that I can figure out where it is on the screen. So let's use it. Let's go to the main somewhere and write out where the ball is in the physics world. So I'm going to write cout b1 dot. Is there a get position? There's two. One's my box 2D and the other is my... Maybe I don't want a second one because I already have one called getPosition. So that might actually be dangerous to have two of the same function. I'm actually going to close that or delete that. And for now, let's just write out the position of the body on the screen. See what it's doing. So I'm going to go into my main and I'm going to go cout b1 dot body. Because that's how it's tied to the physics world. And I'm going to find, now to do anything on the body, you have to press arrow instead of dot. It has to do with the fact that when we made the body variable, we actually put a star there, which says that's a memory address. And if you want to use commands in C++ on a memory address, you don't use the dot. Even though if you press the dot, all the stuff will come up. It won't work. You actually have to use an arrow. I think that's kind of an annoying feature of C++. But anyways, let's look to see if Box2D has a getPosition command. And I'm sure it does. It's called getPosition. Let's see what it is. Actually, getPosition, does it explain it at all? getPosition, it's a B2 vec2. So I'm just going to write .y and see if this thing is moving in the physics world. Because it's not moving on my screen. Right? Let me run that. And see, it's not moving in my physics world either. Okay, I know why. not moving on my screen and it's not moving on my physics world. The one thing that I did when I stopped using this command, which is called display world, was I forgot that this command is important. This is the command that makes the physics world step 1/60th of a second through. And then these numbers have to do with like the precision that it looks at all the forces. I always leave them at 8 and 3. That's what's recommended. So I'll keep that. I need that in there to let the computer know. I need that in my own main. Like probably right before the window clear command to let it, my physics world, know that I want it to calculate all the physics positions. This is basically, this one command is like all the guts of box 2D. It's where all the calculations take place inside of this world.step command. So let's run it. Let's see if the ball falls and if it thinks it's falling. Yes, it thinks it's falling. Okay. And you can see it's falling faster and faster because the Y position's getting smaller and smaller, or bigger and bigger, I guess. Down is positive. But my actual ball is not updating itself to the physics world, okay? That's what we're missing here. We need to, so we have this ball, it's drawing it on the screen, but every frame it has to update itself so it knows where it is in the physics world. This one function here makes it, but it doesn't update its position. So let's make a command. We'll give it the type void. And we'll give it the name update position, like that. It actually doesn't take anything in the brackets either. It's just going to, we're just gonna look into the physics world, find out where this thing is, and then update its position, hopefully. Let's do that. How do we do that? How do we set the position? Because we have a set position command right here, right? So we could just call that command, set position, yeah? And then it's looking for a vector 2f. You can see that there, vector 2f. And it's looking for the position of the ball. So all I need to do is find out the body's position. I have a body here. It knows where it is in the physics world at all time. So if I could just go body, arrow, get position. Yep. Dot x, that's my x part, and body. The physics world's running the whole time in the background and it knows where it is as long as it's running that world.step. Get position dot y. That should update the position of the ball every time. The only problem is if you look in physics.h, you can see that there's this variable, it's called pixels per meter. Box2D does everything in meters, and SFML does everything in pixels. 32 pixels in SFML represents 1 meter in Box2D. So we have to be careful because this number will be in meters, but I want it in pixels. So I'm going to have to times it by pixels per meter. And same with the Y part. Okay, there's a conversion factor there. Times by pixels per, oops. It's already, it'll auto type for you if you type pixels per meter. So that'll make sure it converts the Box2D meters into pixels. That's a long sentence there, isn't it? If you ever want to put it on 2 lines, you can. You just hit enter there. It'll let you. It's just waiting for a semicolon to see if you're running or not. Okay, so that command should run. If we run it, it should update our ball position, hopefully. Let's do it. Let's somewhere in here, maybe after window.clear, we just go b1.update position. So now that will get run every frame. It will go find out where the body is in the physics world, and it will set the position of our ball to that body. Hopefully. Ugh, doesn't like it. Vector 2f is not declared. You have to write SF : vector 2f. Now the thing should move, hopefully. Yeah. Now it's a Box2D object. It's our own object, but it's got Box2D and SFML all blended together. There you go. Boom. Let's add a floor and see if it bounces. It's going to bounce because this command here is figuring out all the equations for us and all the collisions, and it's just going in when we do this, going in and finding our body variable and constantly updating it for us without us even knowing. So as long as we have this body variable and we know it, we will know in the physics world where it is. We let the world.step do all the calculations for us. Our job is just to make sure our SFML shape is getting updated to the body's position in the world. So if I add maybe a floor here or something, we can use some of our old physics code, right? Block floor equals physics colon, we can blend them together, colon, create box, world. I want it at the bottom of the screen, so I'm going to say 0, maybe 600 down. I want it 800 wide, 10 high, and I want it to be a B2 static body. Now this thing should bounce off the floor. Yeah. That's good. Okay. I wanted it to be bouncier though, so when I made this, I made my restitution 0. This is the bounciness of it. But the bounciness is average between the bounciness of the two objects hitting. Bounciness, if that's a word. So I need to find a way to make my floor have a restitution of 0. You can see it's locked in this word called fixture definition, so I'll show you how to do that right now. All I do is go floor, because that's the name of my box 2D body. I hit arrow. All right, get fixture list, and I hit dot set restitution, and then it wants a number in there, so I'm going to give it 0.0. That should make it not bouncy, I think. Maybe this needs an arrow too. Oh, they both need to be 1, I think. See how it's stuck there? If you've ever taken physics, that's a perfectly elastic collision. So I want restitution to be 1, and inside of my ball, I also want it to be 1. Then I'll get unlimited bouncing, which is good. Yes, it comes back, it ends up where it left off. Cool. You can see it updating there. Okay. So I got this box 2D world I've made in my main, right here. I've got my own variable type called ball. Takes on all the properties of an SFML circle shape, but underneath the hood, it also has a lot of the property. It also has its own box 2D body. Okay. That box 2D body keeps track of where it is in the world, and then my only job is to find out where it is in the world and update the position of my ball. And I do that every frame, and then it just moves as if it were in the physics engine. Okay, the physics engine does all the work for me. So let's say I want to give this thing some speed, right? Let's make our own command. Void set velocity. Oops. Set velocity. Okay, and then I'm just going to give it, I need to pass it a number, right? Or a 2D number, so I'll say, you have to write SF in front of all the SFML commands because I didn't put the using namespace thing. But I'll just say I'm going to pass it a 2D vector, and then I'm going to set this thing's velocity. Okay, well I don't really know how to set velocity in box 2D. But somebody must have known, because they would have made it in this physics file. So let's go and rip off their code. Okay. Let's look for a set velocity command. Move body, no. No spin, no. Get velocity, no. Set velocity, right here. Let's steal this command. Okay. I'm going to copy that. I'm going to paste it in my own, except I don't use the word B. I use the word body, because that's what I'm keeping track of. And this person put VEL for their velocity variable, so I might as well do that. Now I have my own set velocity command. So if I look at this thing, bouncy, bouncy, bouncy. Let's try to set the velocity. So what we want to do is maybe turn off our gravity. So we'll set our gravity to 0 in the X and the Y. And then right after we make the ball, let's give it some juice. Let's give it set velocity. Should come up now, should auto type. It's looking for a 2D vector. Let's give it, I don't know, 50 pixels in the X and 50 pixels in the Y. It should go down and to the right now, and then bounce off the wall. Whoa, it's not very fast. 50 pixels per second is actually pretty slow. But it's doing it. We just don't have that wall to the right side. Let's add a wall to the right. Floor, copy, paste. I'm going to call this one R wall. Right wall. So I'll start it at 800. And in the Y direction, I'll start it at 0. You got to figure out where all your walls are going to be. I want it to be 10 wide and 600 tall. Convince yourself of that. I also want the right wall to have a restitution of 1. Okay, so your goal today is to see if you can get all this stuff going and see if you can get a ball to bounce off the 4 walls just continuously there. Boom. Boom. There you go. Pretty slow though right now. 100. 100. Let's make it twice as fast. Yeah. A little bit faster, that's good. I don't have the other walls yet, but that's a good start for today. So just a little recap. We kept our B2 world, same thing. We got rid of our display world command. We made our own variable type by using the word structure. We told it to take on all the properties of SFML circle shape because we like having all the properties like set position, set color, set everything. We copied how physics made a circle in box 2D for the most part. Okay. The only difference is now we have our own body variable that we keep track of. And then we made a few functions for that. Okay. So on Monday we'll make a paddle. Tuesday we'll make some bricks. Maybe some more commands. We're gonna have to come up with some more commands for our ball too. Not just update position and set velocity, but maybe some check collision stuff. Maybe some limit speed, because when we make the paddle and we smash it into the ball, it's going to give the ball speed, which most Brick Breaker games don't do. So we'll have to figure out how to sort that out too. That will be next week. So